In these problems, we have a system of equations, and we're being asked to solve it by graphing. And actually, they give us a bunch of graphs. One of these is going to be correct. You may have solved a system of equations before by using the elimination method, where you add or subtract the equations and try to get rid of one of the variables, or maybe by the substitution method. In this one, you could take x minus 6, plug it in for y up top, solve for x. Those are methods for solving systems of equations. What do they mean when they say solve by graphing? Well, in the situation where the two equations are both lines, that is, they have an x and a y to the first power and maybe some other numbers, what you get is a graph where the lines, if they cross, that is going to be the solution to the system of equations. If you think about it, when you solve a system of equations, you find the value for x and for y that work for both equations. Well, where they cross, that works for both equations. It's a point that is on both lines. So that's what we're looking for in solutions to systems of linear equations by graphing, the point where they intersect. So here, since they've given us the graphs to look at already, we just have to find which one of these pictures matches these equations. And let's see, we have a line with a -3 slope and a line with a slope of +1. So one of them is going to be pretty steep going down. The other one's at a 45-degree angle going up. That looks like a lot like what we have in A here. Actually, it looks like a lot like what we have in all of them, so that's not helping too much. Let's look at the y-intercepts. We have a +2 and a -6. So the steep downward line crosses the y-axis at +2. Well, that is not what's happening in A. That's crossing way above 2, so that's out. Let's see, B, that crosses at a +2. In C, it crosses at a +2. D crosses above that. So we've eliminated A and D. And let's see, the other line crosses at a -6. Well, that looks to be the same on both of these. So what's the difference here? They're both intersecting at this same point. Oh, I see. They've written the answer down here, and one of these answers is written incorrectly. This one says it's the point 2, -4. So 1, 2, and 1, 2, 3, 4. That looks right. And this one says it's the point 2, 4, 2, +4. That would be up here, and that's not where they cross. So in this case, the correct answer is B. Let's try another one. So here, our two equations are y = 7 and y = x. When you have y equaling just a number, no x in there at all, that's going to be a horizontal line at the value y = 7. So like what you can see here in graph A and graph C, graph B and D don't have any horizontal lines, so I think we can rule those out right away. That's good. And then our other line is y = x. So that's got a slope of a +1, which means it's going to go up at a 45-degree angle like that. And that definitely looks like A. It doesn't look like C. C, that's the line y = -x. It slopes downward at a 45-degree angle. And then they cross at 7, 7. That makes sense if x is 7, y is 7. So looks like A is our correct answer. So that's a little bit of work with solving systems of linear equations with graphs.